discussion on the measures of central tendency, we talk about the centrality or the middleness of the distribution. Whereas in the measures of variability or dispersion, we talk about the measures of the average distance of each score or measurement from the center of distribution. The figure at the right shows the importance or significance of the standard deviation under the normal curve. Standard deviation is one of the types of measures of variability or dispersion, so that when we have a small measure of variability, this indicates that the data are clustered around the mean, which means that the data are very close to the mean, or they almost have the same measures or values. It is more homogeneous, less variable, more consistent, and more uniformly distributed. There are three types of measures of variability. First is the range, second, variance, third is the standard deviation. For the range is the difference between the largest and the smallest scores in the set. It is the simplest but most unreliable measure of variability since it uses only two values in the distribution. The range for ungrouped data can be obtained by the difference of the highest and the lowest score, while the group data, the range can be obtained by the difference of the upper limit of the highest class interval and the lower limit of the lowest class interval. For example, under ungrouped data, a business company has the following sales in millions of pesos from April 2020 to August 2020 amidst COVID-19 pandemic. We have 32 million, 27 million, 24 million, 23 million, 21 million. And what is the range? Take note that the range is obtained by getting the difference of the highest and the lowest score. So first we have to determine the highest sales of the company, that is 32, and the lowest sales is 21 million. So the range is 32 minus 21 equals 11 million. Under group data, we have our class interval here in our frequency. The class interval, we have 5 to 9 years old, 7 individuals. 10 to 14, we have 10, 15 to 19, we have 13, 20 to 24, we have 12, 25 to 29, we have 13, 30 to 34, we have 5, and 35 to 39, we have 3, a total of 64 individuals. Here we identify our upper limit of the highest class interval, which is 39, and the lowest class interval of the lower limit is 5. So getting the difference, we have 34. Next is the variance. The variance is the average of the square deviation from the mean. For ungrouped data and group data, we have the sample variance for the ungrouped data, the summation of the square deviation of the individual score from the mean over n-1, while the ungrouped data, the summation of the product of f sub I times the square deviation of the class mark or midpoint from the mean, where I ranges from 1 to k, and k is your class intervals, number of class intervals, n-1. Under ungrouped data for population variance, we have the summation of the squared deviation of the individual score from the population mean over the population. And for group data, we have the summation of f sub I times the square of x sub m minus mu, where I ranges from 1 to k. K is the number of class intervals all over the population size. Mu here, the population mean, x bar is the mean, x is the individual score, n is the total number of sample scores, n is the total number of population scores, and x sub m is the class mark or midpoint of the class interval. Standard deviation, on the other hand, is the average distance of all the scores in the distribution from the mean or central point of the distribution. It is the positive square root of variance. For ungrouped data, we have S is equal to the square root of the summation of the square deviation of the score from the mean over n-1. And for the group data, we have the square root of the summation of f sub I times the square deviation of the class mark from the mean, where I ranges from 1 to k over n-1. For the population variance, we have the square root of the summation of individual score minus mu to the second power, where I ranges from 1 to n over n, And for the group data, we have the square root of the summation of the product of the frequencies and the squared deviation of the class mark and the mean, population mean, where I ranges from 1 to k all over n. This is standard deviation for sample, class mark, the mean, frequency, total number of scores of populations, and total number of scores of samples. Let's have the examples here for variances and standard deviations of both ungrouped data and group data. The second measure of variability is the variance, which is represented by s squared. And the variance can be computed by s squared is equal to the summation of the individual score x sub I minus the mean x bar squared, where I ranges from 1 to n, all over n minus 1. Okay, from this formula, what do we need here? So we need the following requirement. We have to have our mean, okay, the sample mean of that data, and the individual score, okay? So using the formula, suppose we have the column for x or the values of x such as 32, 27, 24, 23, and 21, okay? So these values are the sales of a certain company in millions of pesos. So in order for us to solve for the variance of this set of ungrouped data, we need to get first the sample mean. But the sample mean should have the summation of all the values of X, or we must have the total sales of this company in 5 months. So the total sales is the summation of x sub I, where I ranges from 1 to 5, is equal to 127. So we are now ready to find the mean of our sample data. So the mean is equal to the summation of all the values here divided by the number of values. So we have the summation of all the values of x is 127, and there are 5 scores, or there are 5 data. So the sample mean is equal to 25.4. That is 127 over 5 will give us 25.4. Okay? So now we are ready to find the deviation of each score from the mean. In this part of the formula, x sub I minus mean is the deviation of individual score from the mean. Okay, the individual score from the mean. So we have to get the difference or the deviation. We have x minus the mean. So we take the individual score from x here and subtract it by the sample mean, which is 25.4. And then we square that. We square the result, which is 6.6 squared equals 43.56. Okay, so that is the squared deviation of each score from the mean. Okay, the second one is 27 minus 25.4 is equal to 1.6, and we square that also, we get 2.56. Okay, and the third one is 24 minus 25.4 equals negative 1.4, and we square that, we have 1.96. And the other one is 23 minus 25.4 equals negative 2.4, squared, is equal to 5.76. And last one is 21 minus 25.4 is equal to negative 4.6 or 4.4, negative 4.4 squared. Okay, so we squared that, we have 19.36. Okay, so 19.36. Okay, let us continue. So here, again, the requirement in finding the variance of our sample data here under group data is the summation of the square deviations of each score from the mean. So this is our square deviation of the individual score from the mean. So we get the sum of this, and that is the summation of x minus mean squared is equal to 73.2. So the summation of the square deviation of the score from the mean is equal to 73.2. And take note that our standard deviation, s squared, is equal to the summation of the square deviation of the score from the mean all over n minus 1. So our summation is 73.2 and our n is 5 minus 1. Now we are ready to find the value of our variance. Okay, so 73.2 divided by 5 minus 1 is 18.3. Okay, so that is the variance of the sales of a certain company in 5 months, 18.3 million. But if you want to take the standard deviation of the sales of that certain company, you just get the square root of its variance. Okay, s squared, square root of s squared is equal to the square root of 18.3, which is 4.28. So this is our standard deviation of this sales of the company in 5 months. The variance is 18.3 and the standard deviation is 4.28. So if we're going to square this 4.28, we get 18.3. Or if you're going to take the square root of this, we get 4.28. And remember that the standard deviation is just the square root of our variance, or the variance is the square of our standard deviation. Okay? So that's how we compute our standard deviation and our variance under ungrouped data of samples. In group data, the variance can be computed by s squared is equal to the summation of f sub I times the square of x sub m minus x bar, where I ranges from 1 to n, all over n minus 1. Your f sub I here is the frequencies, set of frequencies, and your x sub m here is your class mark or midpoint, and your x bar here is your sample mean. And then the standard deviation is just the square root of your variance. Okay, so here we have our table. We can make use of this in explaining the way how to get the variance and the standard deviation of a sample data under group data. Okay, so we have the class interval is 5 to 9 with 7 frequencies, 10 to 14 with 10 frequencies, 15 to 19 with 13 frequencies, 20 to 24 with 14 frequencies, 25 to 29 with 14 frequencies, 30 to 34 with 5 frequencies, and 35 to 39 with 3 frequencies. The total frequencies is 64. So the total here is 64. Okay? And the class mark can be computed by getting the average of the lower limit and the upper limit. So 5 plus 9 is equal to 14 divided by 2 is 7. So if you notice, 10 minus 5 is 5, 14 minus 9 is 5, 15 minus 10 is 5, 19 minus 14 is 5, even 35 minus 30 is also equal to 5. So 5 is the class width or the class size of this group data. And then we use that to add to the first class mark in order to get the second, the third, the fourth. We add 5 to each of the succeeding class marks here to get the other class mark. Okay, so the class marks are 7 plus 5, 12, plus 7, plus 5 is 17, plus 5 is 22, plus 5 is 27, plus 5 is 32, and plus 5 is 37. Okay, in our formula, we need our sample mean. We need our sample mean. So the sample mean is obtained by getting the product of the frequency and the class mark and the summation of this product divided by n. Okay, so the frequency 7 times the class mark is 49. 10 times 12 is 120. 13 times 17 is 221. 14 times 22 is 308. 12 times 27 is 324. 5 times 32 is 160. And 3 times 37 is 111. So getting the sum of this, okay, so we have 1,293. And since there are 64 total number of frequencies, then 1,293 divided by 64 is 20.20. That is our sample mean. We need our sample mean in order to get the deviation of the score or the class mark from the mean. Okay, so the class mark is 7 minus 20.20 is negative 13.2 squared is 173.24. 12 minus 20.20 is negative 8.2 squared is 67.24. We have 17 minus 20.20 is negative 3.2. Squared is 10.24. And we have 22 minus 25.22 minus 20.20 is 1.8. Squared is 3.24. 27 minus 20.20 is 6.8. Squared is 46.24. And 32 minus 20.20 is 11.8 squared is 139.24. And 37 minus 20.20 is 16.8 squared. We have 282.24. Okay, so we don't end our discussion here, but rather we go further because our variance needs the product of the frequency and the square deviation of the class mark and the mean. So I multiply our frequency and the square deviation result here. So from here, I multiply here. Okay, so 7 times 174.24 is 1,219.68. 10 times 67.24 is 672.4. 13 times 10.24 is 133.12. 14 times 3.24 is 45.36. 12 times 46.24 is 554.88. 5 times 139.24 is 696.2. And 3 times 282.24 is 846.72. So getting the sum of this product, we have the summation of the product of the frequencies times the squared deviation of class mark, and the mean is 4,168.36. Now we are ready to find the value of our variance. So we have S squared is equal to the summation of F sub I times the square of X sub M minus mean, where I ranges from 1 to 7. 7 because there are 7 class intervals, all over 64 minus 1. So the summation is 4,168.36 divided by 64 minus 1, that is 63. Therefore, the variance is equal to 66, okay? The variance is equal to 66.16. So the variance is equal to 66.16, okay? Or if you wish to get the standard deviation is the square root of S squared, the variance, and we have the square root of 66.16, which is equal to 8.13. Okay, so that is our variance and standard deviation for group data under sample. Okay, and now we are going to interpret or discuss our findings through the values of standard deviation that we have obtained in our discussion earlier under ungrouped and group data. But take note that if the standard deviation value is greater than 1/3 of the sample or 1/3 of the population, then the data is said to be heterogeneous, more dispersed, or less consistent. Moreover, if the standard deviation value is less than 1/3 of the population or 1/3 of the sample, then the data is more homogeneous, less variable, more consistent, and more uniformly distributed. Let's look back at our values on standard deviations for both ungrouped and group data using the sales in the company and the ages of the individuals. For the ungrouped data, the standard deviation of the sales of the company in 5 months is 4.28, which is greater than 1/3 of the sample. Hence, the sales is said to be dispersed, variable, or not consistent due to the enhanced community quarantine protocols. If you notice, the sales gradually decreases as the pandemic progresses. Whereas in the group data, the standard deviation of the ages of the individuals is 8.13, which is less than 1/3 of total frequencies. Therefore, the data indicates uniformity of ages of the individuals. This means that the ages of the individuals are close to the central value of the distribution. This further shows that most of the individuals are older than 20.20 years old. Suppose there are two values of the standard deviations to be compared. The smaller the value of SD or standard deviation, the better. That means that the scores or the measurements are clustered around the mean, or it is more homogeneous than the other one. Okay, or it is more uniformly distributed. So having 2 or 3 standard deviations to be compared with the same unit of measurement, then we choose the smaller value of SD because it gives us a better interpretation or conclusion.